So over here to the right, we have a graph that depicts the problem. The boundaries of this triangle are the line y equals x, the line y equals 4 minus x, and the line y equals 4, this horizontal line. And the points of intersection you could find by solving the system of equations to get those points. And I decided to use the washer method. We're going to revolve that red region about the line x equals -2, which is this line right here, the axis of revolution. You could use the shell method, which would require you to have your typical heights of shells going like this, but then that would change as you cross this boundary right here. If you use the washer method, then we want typical radii of the washer to be perpendicular to the axis of revolution. And we want to use pi times the integral from, in this case, 2 to 4 along the y-axis of the outer radius squared minus the inner radius squared. And so this horizontal distances from the axis of revolution out to the edges of the area that we're revolving, those are x distances, and they depend on the y value between 2 and 4. So we want to solve each of these equations for x. X equals y, and x equals 4 minus y. So the outer radius is the distance from here all the way out to here. And this is the line y equals, or x equals y. So this total distance here is the right minus left, the outer radius is y. Having trouble making a y there. Minus a -2. Right minus left, or y plus 4. Y plus 2. So we're going to square that, and that's what this is right here, the outer radius squared. The inner radius is this distance right here, from here to here. So this total distance is, well, from here to here, depending on y, is just 4 minus y, but then we have to subtract the -2, right minus left. So there's the y coordinate of the x coordinate of any point on this line minus a -2. So the outer radius is 6 minus y. And that's what this expression is right here, the inner radius squared. So we've got pi times the definite integral from 2 to 4 of the outer radius squared minus the inner radius squared. If you square this binomial, and do the subtraction, then find the antiderivative. I'm not going to go through that. You should get 32 pi, which matches what I have here using the definite integral operator on the Desmos online graphing calculator. Okay, hope that helped, and there you go.